Welcome to the new podcast series by Kuraray Europe and its brands for high-tech glass interlayer solutions Trosifol and Glass. With this podcast, we aim to give you practical knowledge and inspiration on all aspects of glass and architecture. What new design possibilities do laminated safety glass solutions offer? And how can our innovative interlayer solutions help improve the acoustics and climate in buildings? With experts from Kuraray, we tackle current topics, both practically and in dialogue. We hope you enjoy this episode and get inspired.
Welcome to our new podcast episode. My name is Björn Sanden, High Performance Manager at Kuraray. Today we're going to talk about something we can't see but has effect on our daily lives. I'm speaking about ultraviolet rays and UV rays. And we will talk about how Trosifol and Glass interlayers for laminated safety glass control the intensity of UV rays for different applications. To help us with this, I've invited Alan Gibson, High Performance Product Manager for Northern Europe at Kuraray. Alan, thanks for being here today.
Thank you, Bjorn. It's my pleasure.
So we are exposed to UV radiation, in fact, almost every day. We usually don't notice it until sometimes it's too late and we get sunburned. But although UV rays can be harmful, they are also essential for life on Earth. Maybe, Alan, you can tell us why that is.
Well, in fact, life without UV light would actually be very, very hard to imagine because all terrestrial and aquatic organisms, they all require this part of the light spectrum in order to survive. And also for us humans, UV light is very, very important. It also helps us to produce vitamin D. It helps to boost our immune system. And in moderation, it can even be good for our skin. Now, UV light also has a positive effect on our moods. When the sun is shining, we feel so much better, don't we?
Yes, and you know what I find so fascinating? UV radiation has a huge impact on our lives and we can't see it.
Yeah, that's right, Bjorn. It is very interesting because the ironic thing is that humans are actually very limited with their sight. We can only see electromagnetic radiation in the range of 400 to 780 nanometers. Now, UV light is below that spectrum. It falls within 100 to 400 nanometers. And then above 780 nanometers, you have the infrared light spectrum.
So, what you're saying is UV light can be both good and bad for us. So in that case, how can Trosifol and Glass laminated glass interlayers help the building designer create a healthy environment for us? I guess they want to maximize the good effects of the UV?
Well, before we get to that, we need to first understand one more thing about ultraviolet light. It is commonly distinguished actually within three categories. UV radiation is categorized as UVA, UVB, and UVC.
Okay, and I guess that these three types of UV rays have different effect on us?
Yeah, that's correct. So UVA, which has a spectrum of 315 to 400 nanometers, this is called near UV. And this is the one that gives you that beautiful tan on the golden beaches or can cause sunburn. And in worst case scenario, it can cause other ailments like cataracts and things like that. Now, this is quite an unusual UV because it's able to penetrate your windows and the clouds of our atmosphere. And then we have the B-type UVB. Now, this is between 280 to 350 nanometers and is also called the middle UV. And this is the type that the plants need for photosynthesis and can also give you that sunburn. Now, it carries more energy than the UVA, and it can actually penetrate windows and clouds very similarly to the UVA. However, in fact, most of the UV that hits the ground, only 5% of that is UVB. because most of it is absorbed by our atmosphere.
And what about UVC?
UVC is between 100 and 280 nanometers, and it's also called the far UVC, UV, or germicidal UV. And this type carries the most energy. It's extremely harmful to all kinds of life forms. In fact, hospitals use this type for disinfection of their rooms because it can effectively kill all kinds of germs and bacteria. However, for us, this type isn't really relevant because the UVC doesn't penetrate our ozone layer, so we don't get it on Earth. The only way we have it on Earth is when we make it manually, so it's man-made.
Okay, so there are 3 types of UV radiations, and each of them has unique properties. So, how is this relevant when it comes to glazing in buildings?
Well, in order to create the right environment, modern buildings need glazing that lets through some UV rays, and some will need UV rays blocked. Now, with Trosifol and Sentriglass, we not only offer an interlayer that makes glass applications in buildings much safer and more stable, but with our UV controlled product portfolio, we offer 2 special types of interlayer that allow UV radiation or block UV radiation over and above that of our standard interlayers. And the need for that can be different depending on the applications.
That's interesting, and I guess that blocking UV radiation is key when it comes to protecting valuable paintings in museums and galleries, right?
That's exactly right, and that's a perfect example, Bjorn. So many materials, plastics, paints, papers, can be damaged with UV radiation, and this is called UV degradation. Now, incidentally, PVB or ionoplasts, the materials we use for our interlayers, are also affected by UV radiation, so therefore our products contain UV stabilizing additives, so they are protected perfectly from aging and can be used long term without yellowing. But coming back to glazing for museums and galleries, for such applications we recommend our Trosifol Extra Protect. It blocks out the UV light in its entirety from 300 nanometers, and this protects the valuable art and artifacts from aging. And other applications where this kind of interlayer is used is libraries, shopping centres, shop frontage, where valuable merchandise needs to be on display but protected from the UV rays, preventing them from discolouring or fading in the sunlight.
Okay, so now we know why in some cases you want to block UV radiation. What I would be now interested to hear is what are typical examples of applications which do require interlayers to allow the UV light to pass through?
Well, almost any application that involves plants or animals. An interesting example, Bjorn, was that some time ago a new ape house was constructed in a zoo. Now, to protect the animals and to allow for all the crowds to view the primates easily, the whole enclosure was encased with laminated glass. Now, standard interlayers block a percentage of natural UV, and this was enough actually to cause a vitamin D deficiency in the apes, and that caused them to be ill and suffer from fatigue.
And what did the zoo do to solve this?
Well, the only thing they could do was to replace the roof glazing with a natural UV. So they used Trosifol, natural UV interlayers in the laminated roof. This material is permeable to UV light, so it allows the natural spectrum of light to enter the enclosure. The apes regained their health very quickly, and in fact the plants within the enclosure also flourished. Now, the further advantages of Trosifol natural UV is that without UV, certain pollinators like bees, they would find it very difficult to navigate without ultraviolet light. So it also keeps a healthy balance of nature, reducing the need for manual intervention with the use of pesticides and fungicides and so on.
Yeah, that all sounds important in time when we need to increase our care for plants and animals. But apart from zoos, what other application is Trosifol natural UV used for?
Well, basically all areas where a full spectrum of light is beneficial. And we're talking about the greenhouses, planted atriums within these beautiful big office blocks, and also quarantine areas. And for more structurally demanding architectural projects, we also offer our Sentry glass in natural UV.
Combination of Sentry glass with natural UV. Why would you specify Sentry glass natural UV instead of Trosifol NUV?
Well, Sentry glass NUV combines the increased transmittance of natural UV radiation with a unique structural performance. In short, it is stiff with the unique coupling effect with the glass. And this allows the use of thinner glazing while still providing excellent UV control and safety. And this would be compared to PVB. In fact, the ionoplast interlayer retains its structural stability even in warmer climates. And a great example of this, Bjorn, would be the Botanical Garden or the Tropenhaus in Berlin. It houses one of the largest and important botanical collections in the world. It was first built in 1905 and was completely renovated only just a few years ago. Now, by using Sentry glass natural UV, 30% of the weight of the glass was reduced. And this protected the historical construction from the weighting and the loading of the glass. But at the same time, the glazing also decreased the carbon footprint of the building, as less structural material, less steelwork, less glass was used, reducing the need for artificial lighting, but also reducing embodied carbon. Now, our UV interlayers are now used in a wide variety of applications, and they would be used in facades, skylights, glass roofs, stair treads, glass bridges even, canopies, railings, and so on and so on. The list is endless.
Well, and it's really exciting to hear which interlayers Kuraray offers for different types of applications with its brands of Trosifol and Sentry glass. But maybe for me and for the listeners, it would be good if you could tell us what kind of support we offer to specifiers and laminators when they have to choose the right solution for a specific project.
Well, I suppose the most common way is to pick up the phone and speak to us. You get so much more information by having a conversation with someone and being able to discuss their needs and match those needs with the quality products that we offer. But as well as that, we offer various calculation tools, free to use, and can be downloaded from our website for your phone, your application, or your laptop. And these include things like Trosifol Glass Global. This allows you to calculate static loads in various different conditions, and then work out the calculations from those load characteristics. We also have a SoundLab application, and this is able to help with the acoustics. And we actually mentioned this in a little bit detail with the acoustics seminar and also the podcast that we produce for acoustics. But for this particular subject, Trosifol WinSLT is really the right choice for all calculations that have to do with light.
Okay, yeah, I have used WinSLT. It is a nice application, but maybe you want to tell us a little bit more about it.
Yeah, well, WinSLT allows the calculation of light and energy transmission. And to make it easy for users, you can choose between different standards, whether it be DIN, American standards, or European standards. And the app has the ability to include within it 4 different coatings. You can choose from UV protection, low emissivity, a combo of low emissivity and UV protection, also self-cleaning coatings. And you can choose the glass construction, the type of interlayer that's being used, whether it's an insulated glass unit, a double glazed unit, and so on. So after the calculation, the customers simply receive all the results by report sent to their email address. And the results include things like U value, G value, and of course UV transmission.
Yes, it sounds really like a helpful tool for our customers. So, Alan, we're almost at the end of today's podcast episode, and I have really enjoyed talking to you. One last question, however, before we wrap up today. Where can our listeners find more information about the different solutions for UV control with Trosifol and Sentriglass?
Well, our website, we have a huge collection of all the material that would be required, whether it be our product brochures and all the relevant, useful analysis data and test data. We have special application documents, so these are documents like salt spray testing and all the relevant test data that relates to that. But I think you get a lot of information by looking at the project case studies. There you can see certain glass construction types actually in situ, serving their purpose, and you can understand a lot more about why they were used for certain applications. We have this podcast and all the other podcasts that we've done. In fact, there's too much to list. I really would recommend that somebody go onto the website and have a look. And for more specific questions, myself, the rest of the team, and yourself included, Bjorn, are very happy to answer any questions. So all I say is pick up the call, pick up the phone and give us a call.
Okay, thank you very much, Alan. This was really interesting and very useful information.
You're very welcome, Bjorn. Thank you very much for having me.
Thanks for listening. We hope you found this podcast useful and that you now know more about the innovative interlayer solutions that Trosifol and Sentriglass offer you for your architectural and engineering projects. For more information, please contact our technical service or look at our website at trosifol.com. And don't forget to tune in again next time for more information on Kuraray's glass interlayer brands Trosifol and Sentriglass. See you then.